Hi there. Now if you've been watching the previous video in this series, you'll know I was talking about dependent events and drawing probability tree diagrams for them. Now I've got another example here that you might like to try now on your own, so we'll read it together and give you time to pause the video, say, and we'll work through the solution. So we've got a disease is known to be present in 5% of a population, and a test is developed to help determine whether or not someone has the disease. If a person has the disease, the test is positive with a probability of 0.9. And if a person does not have the disease, the test is positive with a probability of 0.03. We've got to find the probability that the test is negative for a person selected at random from this population. So if you'd like to have a go at this, just give you a moment then to pause the video. When you come back, either fast forward to check your answer, or I'll take you slowly through the solution. Okay, welcome back if you had a go. So the first thing we do, draw some trials for this event. A couple of trials. First one is about the disease. Next one's about the test result. Obviously you might have different names here. Doesn't really matter. But as for the tree diagram, you're going to have a tree diagram that should look something like this. So for the population, we know that some people, 5% of the population, have the disease, and that would mean 95% don't have the disease. So if you put those probabilities in, the probability of having a disease, which I've given as the letter D, is 5% or 0.05. Probability of not having the disease then must be 95% or 0.95. And then we go on to test to see what the result's going to be, whether it's going to be positive or negative. And that probability is dependent on whether a person has the disease or doesn't have the disease. And so if we take this branch as being the probability that someone tests positive given that they have the disease, then we can see that that's 0.9 here. And I showed you that you would write that something like this. I've chosen the probability of being positive given that the person is known to have the disease. And that's the 0.9 that we've got up here. And that would mean that the probability of testing negative, given that you had the disease, must be 1 minus 0.9. That's got to be 0.1. And you'd write that probability in, say something like this. And when we come down here, if the person didn't have the disease and then has the test, the probability that they test positive, given that they didn't have the disease, we're told is 0.03. So if you put that probability in, you've got the probability of positive given that they don't have the disease. That's 0.03. And similarly now, we know that the probability of testing negative, given that they do not have the disease, must be 0.97, 1 minus the 0.03 we had here. And so when it comes to finding the probability that the test is negative for a person selected at random from this population, then you'd write something like this then. Probability of testing negative is equal to the probability of D followed by being negative. That's this line here. Plus, because we're dealing with a mutually exclusive event, an OR situation, that is this other branch down through here. That's the probability of not being defective, and then carrying on to test negative given that it was defective. So that's that one there. And you can write that notation in here with those dependent probabilities. And if you then substitute the decimals that we've got here, enter them in, you'll find that you get this sum to do. Working that out gives you 0.9265. Okay, so I hope you're able to get that right, and you've got a good understanding now of working with tree diagrams that involve dependent events, okay, where these probabilities have this notation now. Okay?